Logistic regression. Logistic regression is a supervised learning algorithm used for binary classification problems. Example, yes, no, spam or not spam. Instead of predicting a continuous output, it predicts the probability of an observation belonging to a particular class by applying the logistic, which is the sigmoid function, which outputs values between 0 and 1. So let's go ahead and write code for this. Here is the line by line breakdown of the code for implementing logistic regression in Python. So first step, I'm going to go and import the necessary libraries. Now from sklearn.linearModel import logistic regression, this imports the logistic regression class from sklearn, which is used to create a logistic regression model. Now, the logistic regression is typically used for binary classification tasks, as I mentioned, where the goal is to predict one of the two possible outcomes. Next, from sklearn.modelPrediction, import train test split. This imports the train test split function, which splits the dataset into training and testing sets. This allows us to evaluate how well the model generalizes to unseen data. Next, from sklearn metrics, import accuracy score and confusion matrix. This imports accuracy score, which calculates the accuracy of predictions, and confusion matrix, which provides detailed insights into the model's classification performance, showing the true positives, true negatives, false positives, and false negatives. Next, we'll import NumPy as NP. This imports the NumPy library, which is fundamental for numerical computations in Python, especially for creating and manipulating arrays. So now let's go ahead and create those sample data. We have our studies versus pass and fail. So first is x equal to np array, and I've mentioned how many hours you studied, which defines the feature data x as a numpy array, where each element is a list representing hours studied by a student. Here the shape of x is 10, 1, indicating 10 examples or rows with one feature, which is the column. Next, I have y equal to np array. It defines the target data y as a numpy array containing the outcomes of the study hours, where 0 represents fail and 1 represents pass. Now this is binary classification task, making it well suited for logistic regression. So let's go ahead and next split the data into training and testing sets. I can do that by calling that train test split function, which splits the data into training and testing sets. We have xtrain and ytrain, which is used for training the model, and we have xtest and ytest, which is used to test the model's performance. The test size is specified as 0.2, which specifies that 20% of the data should be used for testing, while the remaining 80% will be used for training. Our random state is 42, which sets a seed for reproducibility, ensuring that each time the code is run, the same data split is generated. Now let's go ahead and initialize and train the model. To do that, I am going to start with model equal to logistic regression. This initializes a logistic regression model. Now the logistic regression will find the best fitting logistic or S-shaped curve that separates the binary outcomes. I'm going to go ahead and say model.fit and pass xtrain and ytrain, which trains the logistic regression model on the training data xtrain and ytrain. The model learns the relationship between hours studied and the pass-fail outcome, estimating parameters that allow it to predict binary outcomes. Now let's go and make predictions. Ypred equal to model predict xtest. This uses the trained logistic regression model to make predictions on the test data xtest. The output ypred contains the model's predictions, where each value is either 0 fail or 1 pass, corresponding to the model's estimate of whether a student passed or failed based on hours studied. Now let's go ahead and evaluate this model. I'm going to use accuracy score, ytest, ypred. This calculates the accuracy of the model by comparing the actual values ytest to predicted values ypred. Accuracy is the ratio of correctly predicted instances to the total instances. Next, confusion matrix equal to confusion matrix ytest, ypred. This computes the confusion matrix for the model, showing a breakdown of true positives true negatives, false positives, and false negatives. This helps to understand the model's classification performance in more detail. Next, we print the accuracy and we'll print the confusion matrix to check the results. So this code provides a complete example of a logistic regression workflow, including data preparation, model training, prediction, and performance evaluation. This is particularly useful for binary classification tasks where the goal is to predict one of the two outcomes, in this case, fail versus pass. So let's go ahead and run this project. I'm going to save it, go here and say Python logistic regression. And there you go. Our accuracy is 1.0. Confusion matrix with true positives, true negatives, false positives, and false negatives is displayed right here. I hope you were able to follow along and implement this. If you have any problems, questions, let me know in the comments and I'll get back to you.